alpha, this is beta. Exactly at this point, P, you have to determine the field. Lambda is the linear charge density. It's a finite rod. It's having some length L. So that instead of the length L, we have here alpha and beta. What are alpha beta? The line joining the ends with the point P will subtend an angle alpha and beta with the horizontal. What is the small d? The perpendicular distance from the rod. At point P, we have to find out the electrostatic field strength. This also I did in gravitation. I'll give 3 minutes time. You must work out. In fact, it's very lengthy. Okay, take 5 minutes. Okay, you open your notebook and start working. So do we have any formula for a long rod? No, we don't have, like for a finite rod. There's a finite rod. Finite thin charged rod. Okay, now if you can get a formula, then what happen? We can really modify this for many other situations. Finite thin charged. If alpha beta 90, it will become very long, thin, long charged rod. If beta 0, alpha 90, it will become semi-infinite long rod. Like that, the conditions will come. If alpha equal to beta, it will become like a finite rod where you are finding out the field on the bisector. So just by varying alpha beta, we can go for the different conditions here. So instead of working 4 different numericals, let me work out only one numerical. Then I'll put a condition for alpha beta. I'll get one generalized formula so we can discuss many situations. Got the idea now? What was my intention? Okay, now we have to find out the field strength at point P. I'll make it small. The another one will keep all the modifications. Try it. It's a very good mathematics for you. Good mathematical drill. I think the page, I may need 2-3 pages. Huh? Okay, anyway, we'll manage. Shall I wait or shall I continue? Shall I start deriving or you want to try?
We'll try, sir.
We'll try. Okay, then I'll give 3 minutes time because I can't wait 10 minutes.
Yes.
Come on. Yeah. Don't type anything on this website because nothing is available. It may because we are very busy in college work. No, I'm not getting any time to only just domain name got it. Maybe it will take another long time. Nothing new. What all your the videos and the notes will be available there for you. On planning some assignments, good assignments and tests if time permits. Yeah. What we have to do, our answer should come, the field strength at point P should be in terms of lambda, small d, alpha, and beta. Because these things are known for us. Lambda, small d, alpha, and beta. In terms of this, the final answer should be there. Close door. I'll close the windows. Okay, let me begin. I'll feel bored sitting ideal like this. I'll start this one. So let me assume a small element. Fun. So let this here, this will be DE dash, you write it. So this angle, let it be theta. Let this be phi, let this be phi, and let this be R. So what is this? Now D phi will be the angle subtended by this element at point P. This is a point P. Okay, let this distance be equal to X or Y, anything. I'll take Y. Then this will become dy. So there's an elemental charge dq. Okay, no. So this is our base diagram, the alpha beta. Now what I'm finding out is the field strength at point P due to this small element of charge dq, that one. So let this be dE dash. Okay, now the conditions will be dE dash should be equal to first only from Coulomb's law, k dq by r square. What is further r dq all that has to be substituted. Now in the vector form, what is dE bar should be equal to dE dash cos phi I cap minus dE dash sin phi j cap. dE dash, what we can write, k dq r square cos phi I cap this is a resultant dE bar. Further, what is dq? Lambda into dy. Okay, if I go for integration, what is the biggest problem? This angle is varying, this angle is varying, this r is variable, this dy is variable, this is unknown thing. So how many variables are there? 3 variables are there. When do we can integrate? When one unknown, one variable should be there in RHS. This is unknown thing. Okay, I'll integrate. Here the variable should be only one, but we're having here variables for what is this angle phi, phase the phi, the dy, and also the r. So now I should look at the mathematics where I can simplify. I can everything. This should be RHS should be converted into one variable. What is the best variable? Let me pick up the angle because d phi will vary from alpha to beta. So let me eliminate these two things in terms of angle phi. Okay, for that I'll look at the cos phi is equal to d by r. So r equal to d secant phi. There's the one thing. Next, similarly, tan phi is equal to y by r or y equal to r tan phi. Let me substitute these things here. Y by d. Yeah, okay, fine. Yeah. Okay, let me substitute these things here. K lambda dy will be okay. Dy is needed. D secant square phi d phi. So this will be dy is equal to d phi. R square will be d square secant square phi. This is cos phi I cap. Dy will be k lambda. This will be by d. K lambda d. Okay, fine. I think we are in for better good position. Now I have to go for the limit. What should be the limit? What shall I do with the limit? See, there's an angle. If I measure the angle in this sense, means I want the field strength due to upper segment of the rod. Due to upper segment of the rod. Then this angle d phi will vary from 0 to plus alpha. This angle will be 0 degree line. If I vary the angle from 0 to plus alpha, I'll get the field strength at point P due to the upper segment of the rod. Then how do I want the field strength due to lower part? Then I should like I rotate this angle in opposite sense. If this sense, if I rotate, will be positive, no? The angle. So then the field due to lower part will come only when you rotate the d phi from 0 to minus beta. Look at the alpha and beta, they're measured in opposite sense. I'll take this clockwise as positive. The counterclockwise will become negative. So the limits here will be zero to plus alpha. Also, like this will be minus beta to plus alpha. Once again, I'm putting 0 to plus alpha, 0 to minus beta, or the limits will be from minus beta to plus alpha. So solving this will become E bar equal to K lambda. Integral of cos phi will be sin phi. Integral of sin phi will be minus cos phi or this E bar will become K lambda D sin alpha plus sin beta I cap. Negative of negative, this will be positive. K lambda D cos alpha minus cos beta J cap. I think there's a very generalized formula. If you can remember so many conditions, you can take it. I think such formulas, no. So any numerical with a finite rod, you can easily manage with the help of this one. Okay, see once the total description is at one place. Alpha beta, as the for the different numericals, I'm going to substitute it with different signs. Completed. Okay, let's go for now.